Everybody, for taking some time out of your day to hear how Lattice and Teledyne FLIR have partnered to make our roads safer for vulnerable road users like pedestrians, bicyclists, motorcyclists, runners. And this partnership has really been very exciting for us at Teledyne FLIR. It's a continuation of work we've been doing in the automotive space for quite some time, and I'm excited to tell you about it. We'll start first with a little video that gives you an idea of some of the various ways that Teledyne FLIR is impacting the world for good with thermal imaging technology.
Us to just be able to find them a lot quicker. One person over here doing that instead of a whole patrol of officers going out. One person can do that, and then we can direct either the canine or officers into that direction.
He's walking eastbound. Go ahead.
Traffic Safety Administration finalized a new rule that will require all new passenger vehicles to include automatic emergency braking.
This is the best thermal camera ever on a drone this size.
So you saw in the video some ways that thermal imaging technology can be used, but what does a thermal sensor see? It's amazing. I've been in this business for a while, and still thermal cameras and technology are new to a lot of people because we're just really at the beginning of moving out of some of the military applications and into industrial and broader applications, and even into your hand in rugged smartphones. So a thermal camera, we're looking at radiation that's beyond what your visible eye can see. So we're sensing in the 8 to 14 micron part of the electromagnetic spectrum, well beyond what we can see with our eyes, around 0.65 micron, something like that. And the radiation we're looking for, it comes from heat that is emitted by every object on Earth. So every object above absolute zero has a heat signature. So this gives us the first main capability of thermal cameras, and that's night vision, the ability to see in absolute darkness. Another example that you saw in the video, because we're looking at these longer wavelengths, a firefighter is able to find a person that's trapped or inside a burning building. So we can see through the smoke, find the people, and then safely guide the firefighter out of the burning building. Since we're measuring thermal energy, everything we do is about heat, we can make non-contact temperature measurements as well. So those non-contact temperature measurements are generally a sign of wear or impending failure in mechanical and electronic systems. So we can translate that information into preventative or predictive maintenance. Coupling a thermal camera with powerful optics, you're able to have a visibility of multiple miles, 2-3 miles. So this can provide excellent capability to secure, say, a critical infrastructure like a power plant or a nuclear facility. And then what the talk will focus on today is taking this thermal technology, making it something that can be in every car that we own, and really give the vehicle a complementary sensor to the visible sensors, to LiDAR, radar, whatever other sensors the car maker may use, to really provide that extra element of safety at night and in other conditions that we'll talk about. So as somebody who spent about a decade of his career when imaging in mobile phones was taking off, very exciting time. Photography was a hobby as a kid. Imaging has always been fascinating. And the connectivity we've been able to achieve with cameras that we carry everywhere is really amazing and something that was hard to imagine 20 years ago. But I think you saw in the video, and you'll see more today, thermal imaging, it tends to have an immediate impact that's not only life-changing, it's like life or death, and can make just a huge impact in people's lives and people's safety. So what is the problem that we're trying to solve as Teledyne FLIR and brought us together with Lattice? This is kind of a grim statistic. If you look at the blue curve there, those are the pedestrian fatalities that happen on U.S. roads. And all of the other more or less flat curves are other countries. So around 2007, pedestrian fatalities in the U.S. started to increase. And there's debate among experts around what the cause of these rising pedestrian fatalities are. There seems to be two critical factors. In the US, we tend to drive larger vehicles. So we drive trucks, we drive SUVs. They cause more damage when we collide with a pedestrian. The other factor that happened around 2007 was the introduction of the smartphone. So we have smartphones becoming prolific, and we have distracted driving. So these two factors are leading to this rise in pedestrian fatalities. So over 7,000 people a year are killed in the US in automotive pedestrian encounters. And when do these deaths primarily occur and where? They primarily occur, over 3/4 occur at night and generally on poorly lit roads. So being able to give the vehicle better situational awareness and the driver better situational awareness at night is a significant problem that we're trying to solve. The problem grew to such an extent that last year, in late April of this year, NHTSA introduced a new regulation saying that all vehicles need to have automatic emergency braking, but they made it much more consistent with the real world. They said the automatic emergency braking has to be functional both at daytime but at nighttime, and they moved the speed limit previously, as shown by the black flag here. The speed limit was 25 miles an hour, so your automatic emergency braking system had to work when you were traveling relatively slow speeds. But this is a histogram, another gruesome statistic, so I apologize, but these are the speeds that the deaths happen. So very, very few people, very few pedestrians, as you can imagine, are killed by collisions of less than 25 miles an hour. In April, NHTSA moved the bar. They moved it to 40 miles an hour. During NHTSA's period of notice of proposed rulemaking, as Teledyne FLIR, we suggested a higher speed limit, maybe 60 miles an hour. And we think in the fullness of time, as the technology evolves, NHTSA will increase the speed limit that's required for automatic emergency braking in vehicles. There's about another third of the pedestrian fatalities that happen between 40 miles an hour and 60 miles an hour. And we think we have the answer. We have the technology, and we think it's affordable and will be a big part of the solution. So what are the NHTSA tests that they introduced in this new rule in April? They're basically a number of real-world scenarios, not unlike I encountered this morning on my trip to Starbucks. I was driving along a fairly unlit road near the East Foothills here in San Jose. There was a bit of a dip in the road, and there was a pedestrian crossing the street wearing blue jeans and a dark coat, and not at an intersection, not at a corner. And, you know, it was alarming, especially before your first cup of coffee, to like, there's somebody in the middle of the road. This is dangerous. And I think we've all experienced those things many times. So the type of conditions, there's pedestrian crossing of the road, there's a pedestrian walking in the direction of the vehicle path. Maybe this would be a jogger in the real world. And then probably the most challenging condition is shown in the bottom here, a pedestrian or a child emerging behind a parked vehicle. So this makes two things kind of challenging about this scenario. Detecting objects with machine learning, it really comes down to data and essentially how many pixels you have on the target to detect the object. So if I'm facing a vehicle, standing in the lane, running in the direction of the vehicle path, you have lots of pixels of me on the target. If I'm turned sideways, like I'm crossing the street, I may still have a lot of pixels, but less pixels than when I'm facing you. So these are the test conditions that NHTSA established. And how can a thermal camera help? Well, we talked about how we can see in absolute darkness. So it doesn't matter if it's day or night, street light, no street light, the thermal camera will see the pedestrian. What a lot of people don't realize is thermal cameras are also very, we keep sensing day or night. And so there are a lot of situations that we encounter in our daytime operation of a vehicle where a thermal camera can be a great assist. Since we're looking at heat, not light, if you're driving into the rising or setting sun, something that tends to make us squint and kind of blinds a visible camera with glare and flare through the optics. A thermal camera, the sun, as you can see in the middle picture, just remains a disk in the sky and is not an issue. And we talked about smoke, getting in and out of a smoke-filled building for a firefighter. But with a thermal camera, we're able to see, since we're looking at those longer wavelengths, the radiation we're looking for from the target is not diffused or reflected due to the particles in the fog generally, and we're able to see through that fog and make out the pedestrian that we'd have trouble seeing with our eyes. So there's a lot of benefits thermal cameras bring. What did Lattice and Teledyne FLIR bring to this party to make a very affordable, functionally safe, as Sebastian mentioned in the last keynote? This is actually the first automotive safety integrity level B thermal camera. And essentially what that safety level means is you're able to trust the data from the thermal camera to control the vehicle. So we have a lot of functionality built into this automotive-specific thermal camera designed to do data validation. We check to make sure that we're receiving continuous frames, that we're not stuck, that the image is not obscured. So we bring that as well as some monitoring functionality to the camera. Teledyne FLIR, we've been making thermal cameras for over 50 years. So thermal cameras, thermal sensing, that's what we do. So our engineers, we developed the MEMS thermal sensing process, the microbolometer sensor process that we use. We designed the readout IC, which multiplexes or connects each pixel in our camera array to the data stream. We also do a large amount of sophisticated analog compensation within the sensor. Thermal sensors are quite sensitive, but there's also a lot of pixel-to-pixel variation, and there's a lot of variation over temperature in the pixel signal. So we take care of that part in the sensor itself, but this is where Lattice really brings a lot to the party. Since we're measuring temperature, low power is incredibly important. We can't have basically a thermally noisy electrical device that's powering on, powering off, really pressing our ability to compensate those thermal changes to the max anywhere near the sensor. So low power, absolutely essential. The flexible logic, incredibly important. It allows us to interface our proprietary sensor interface to the gate processing and compute power of the Lattice FPGA. And then on the output side, we're able to leverage Lattice IP to create a MIPI data stream that talks to the SerDes that can allow the camera to communicate with the rest of the vehicle. So a lot of power that Lattice brings to this, and we've really benefited from the partnership. You get some idea of the scale of our thermal camera in the images at the bottom. And this was our second and third generation automotive camera. So working with our engineering team and working with Lattice, this automotive camera, I think we've done a good job together to achieve a pretty significant size reduction. And okay, so we got the size, but did we give up on the image to get the size? And I think the best way to show that, we have a little demo here. And we'll switch the screen to the demo, and you'll get to see yourselves in thermal, we hope. That's not us. Yeah. Maybe, yeah. Unfortunately, you'll have to look at a video a little bit later in the presentation, but we were hoping to show you all glowing like light bulbs so you could see yourself. And then the real kicker is we turn the lights off and nothing changes. We're basically all very strong thermal signals. So you'll see that in the video coming up. A little bit more about the collaboration with Lattice and the partnership. And you know, these are our engineers' words, not my words. There's a lot of alignment that Lattice brought to the party. They gave us very early roadmap visibility. So we are in this automotive industrial market space where you have very long life cycles, 7 to 12 years type of life cycle. So you want to make sure that you are making the smartest decisions, using the most advanced technology when you're doing the design. But if you jump too early and your partner doesn't deliver, you're orphaned and you're stuck and you'll miss your customer deadlines and a whole lot of pain. So Lattice gave us that roadmap visibility that enabled us to make a design decision for the Certus Pro before first silicon was available. So you have to have a lot of trust and confidence in a partner to make that kind of decision. And then they were true to their word and really delivered the ecosystem to make a product. An FPGA by itself, as low power and powerful as it can be, is not a product. So Lattice committed to working with the memory supplier to develop the memory controller IP so that we could integrate a very small memory in our camera. And that memory is crucial because I mentioned earlier, we require per pixel data corrections. We have to access basically the per pixel correction data that we stored during our calibration process as the first step in our image pipeline, or you just get a completely noisy image and really no thermal image that you could make use of downstream. So a really tight partnership. Lattice helped us identify problems early. Chuck told me when I was talking to him about this, and we've lived this experience in the design of this camera. Chuck told me it was like I had my own dedicated applications engineer. And I think this is concurrent collaborative engineering at its best. Chuck would find a problem, Lattice would help work the solution very quickly. And there's just this beautiful back and forth that led to a really rapid design. Is it working now? Okay, so let's try this again, okay? We'll switch to the thermal image. There you go. All right. Okay, yeah. So imagine you're driving in that desert or you're driving on a rural highway, no street lights, no moonlight. This certainly provides a great amount of situational awareness. So I think you can see, begin to appreciate for yourselves what a thermal camera can do to improve a vehicle's situational awareness. So thank you. So we got the size. We didn't sacrifice the image quality. In fact, the image quality is better than ever in this small size. But can we pass the NHTSA test requirements, the FMVS, Federal Motor Vehicle Safety Regulation 127 that was issued in April? So in August, September, we basically put this to the test. We adapted a forward fusion with our partner VSI, and we had our vehicle, we had the automotive thermal camera. We spent a large amount of time tuning a Sony high dynamic range 8 megapixel visible camera because we wanted to mimic current vehicles. And then we also had a radar. So the cameras are detecting and providing input to classify objects, and the radar is telling us distance, and then we're able to talk to the vehicle's CAN bus and apply the brakes. We wanted to really see how we stacked up with the best in vehicles that are on the market today. So we tested 3 2024 models that we thought to be really the best in class, best safety cars out there. And this, and they had a variety of sensors, but primarily they relied on either a visible camera, stereo visible cameras, or a combination of visible and radar. The OEM 3 line, that was actually a visible camera and a radar, not a thermal camera. And then the dots here show you what different targets, when you're testing automatic emergency braking with a thermal camera, it's important that the test target, this pedestrian test mannequin, has a heat signature. So previously, the targets have been styrofoam type of bodies. We used a target from a company, 4Active, that's actually a heated target and has a heat signature. And you can see the target next to some of our team that was there on the test track in Detroit in September. So we put this system to the test, and this video, you have the high dynamic range visible camera on the left, you have the automotive thermal camera on the right. You can see that we're identifying and classifying the pedestrian in the roadway, that thermal pedestrian test mannequin from a very far distance. So things look promising, but could we pass all of those combinations that NHTSA is prescribing? Fortunately, yes. Our vehicle is the leftmost column. We passed all the tests day and night. And then you can see across the board these three 2024 OEM models. The automatic emergency braking has actually improved very significantly from when we conducted similar testing 4 years ago with these type of vehicles, but all of them fail one or more of the tests that NHTSA is mandating. And today, we just published a white paper describing these test results in more detail. So if you go to the link on the barcode in the slide, you can actually download the full report and find out the names of these 3 car models that we tested, see if you're driving one of them, and just get a better understanding for the practicalities of automotive safety. The real advantage that thermal brought in this situation is the ability to detect and classify the pedestrian from a much larger range, particularly at night. So in the NHTSA specified test, we're able to detect the pedestrian 2 or 3 times further at night than the visible camera. That gives you the ability to gradually slow down, not a very abrupt type of braking. And one area that we think thermal cameras will really add to is the comfort of the driving experience and eliminate a lot of false positive brakings that you'd have to deal with if you didn't have that thermal data. And that can be an extreme nuisance. I think many of us have experienced these with our vehicles when the car wants to, its ADAS features wants to keep you in a lane when you're trying to change a lane, or when it's trying to do things and sort of take control from you as the driver that you don't expect. And that kind of abrupt false braking would definitely cause people to not use the technology. And as a place we think, again, that thermal will really provide safety and comfort to the driving experience. So wrapping things up, the partnership between Teledyne FLIR and Lattice continues. It really started in earnest with the development of the automotive camera using the Certus Pro. We have a development going on now with Avant for a higher resolution, higher performance thermal camera. And one of the big advantages of sticking with the Lattice family is this higher resolution program was able to leverage a lot of the image pipeline coding that we've done on the automotive camera, and that team got a real lift by reusing the bulk of that work. So that's a great advantage. And then I'm sure, like most of your customers, our automotive customers have extreme expectations about the cost roadmaps they want to see and the cost downs they want us to achieve. And we want to achieve them as well because we want thermal cameras on every vehicle. We want to bring this safety to every vehicle. So going forward in some of our future-looking automotive products, we'll move to the cross-link Lattice FPGA and believe that this can provide a real step function for us in cost reduction. So a great partnership. Thank you, Lattice, and thank you for your attention.